Hi, ladies and gentlemen. My name is Derek Tsai from learnbyblogging.com. Today, I want to review this book called Think Bayes by Alan Downey. So this is the book that I'm going to give you some. I'm going to give you a review on this one. Think Bayes, a very nice book. So I vaguely remember ever learned about Bayes' theorem in college until I read this book. And I never thought there were so many applications of Bayes' theorem in our daily life. The drug company use it to get FDA approvals on drugs. The food company applies the theorem to prove certain foods are good for us or not good for us. In a way, these theorem allow us to change our perception of certain events, probability of occurring, the occurrence probability. I can imagine more and application, the one that that's outlined in this book. And by the way, the PDF format of this book can be freely downloaded in my link over here in my website. Thanks to the author's generosity, he pretty much given the book freely away. The book gets very technical fast after the first chapter, which really piqued my interest with the cookies, the M&M, the Monty Hall problems, very interesting problems. But at the end, I don't know if it's really necessary to know all the various applications in the predictions and simulations. But it could come in handy for the people who actually work in this statistical field. The key things to remember about Bayes' theorem is that it gives you a way to arrive at a posterior probability of a prior known hypothesis. Okay, that's a mouthful. So if you have after learning some new piece of data, new piece of information, and you have some hypothesis in the past, and that you want to, with additional piece of data, you can arrive at a posterior probability. So the equation is quite simple. The probability of the hypothesis given the data, okay, so it's H bar D equals to probability of the hypothesis times the probability of the data given the hypothesis. So you have some established probability based on the old data and divided by the probability of all the data occurrence. Okay. Turn out the most difficult part is actually getting all the probability of the data occurring right. So, we call it the normalizing factor, excuse me, which is the probability of seeing the data under any hypothesis at all. Okay. So overall, all the concepts presented by the author makes sense to me. But I'm not sure I can truly implement and devise a model when the actual problem arrives, but at least I can recognize the Bayes' theorem when I see one and know where to find help. This is the book I would look to. So on the chapter by chapter summary, the chapter 1, the Bayes' theorem was derived and very easily and discussed. Mr. Downey introduced a probability calculator of getting the heart attack. So there's a link that gives you all the probability of getting a heart attack within the 10 years time span, provided you answer some of the questions they have. And chapter 2 is computational statistics. The author provides a set of Python codes and tools to calculate the results very quickly. Turns out I had to retake the Python refresher course. Actually, his other book called Think Python book. I have another review on that book. I need to review that before I get any further, but the tools are powerful and help me understand the subject matter a little bit better. And all the codes are downloadable from thinkbayes.com website. And it took me a while to figure out the Monty Hall problem. One of those paradoxes that's very hard to sink in. If you don't know what it is, go ahead and Google them. And chapter 3 is about estimation. So this chapter estimates the posterior probability upon rolling the multi-phase die, the 4-phase, 4-sided, 6-sided, 8-sided, 12-sided, 20-sided die. And then if you have a successive rolling of the dice, means that you have more data points that change the probability distribution as well. And the probability of number of locomotive or trains given the observation of one locomotive number. So that's not very interesting. But that's when you really need to have the computer to do the work for you, because it gets very complicated. But the intuitive part is that the more information you have, the better is your estimation is going to be. Well, as some data points can be ruled out. For example, if you find a 6 in the row of in this experiment of 4-sided, 6-sided, you can pretty much rule out the die, the 6-sided die being one of them. Okay. Now, chapter 4 is about more estimation. This chapter, the author covers the bias euro coin problem. So the interesting phenomenon is that the prior hypothesis makes very little difference, provided you don't rule them out with a 0 probability. So always put something in there, even though you know there's a remote chance, no possibility, but put it there so that you can still have a probability that can happen. And the posterior distribution likely converge with more data points. Okay, that makes sense. Chapter 5 is about odds and addends. The author covers the odds form of the Bayesian theorem. And if you do there's an equation there. It's much easier to understand for most people. The addend parts of the chapter going into getting the density and the distribution function. So another more of a mumbo jumbo. Chapter 6 is decision analysis. So you're given a prior distribution function. What is the best decision to make given some data points? Okay, given some data. So the author presented the Price is Right scenario, and this is the the best price to bid for a showcase showdown, given that you know what are the distribution of the price range in the past. So in this particular chapter, you need to apply the PDF, which is probability density function. It's introduced here, and also the use of KDE, which is a kernel density estimation. This is to smooth out the PDF that can fit the data. If your data is very jagged, you need to smooth it out. So this is an interesting application of the Bayes theorem. The math is complicated and cannot be done without a computer. So I guess it would be good to bring your computer to the Price is Right game if they let you in. Chapter 7 is a prediction. So here the author presented the better way to predict the outcome of a playoff game score based on the past data between the two teams. So he gave an example of Boston Bruins versus Vancouver Canucks. This should be no different than from a gambling industry when they give you computer odds before the big game. Just imagine all the gambling earning you can earn by mastering this particular chapter. So that's motivation there. I'm not sure someone has applied the same. I'm pretty sure somebody already applied the same ideas and theory to the financial market, like stocks, bonds, and futures market. So that was my motivation as well. Hopefully I get rich from that. Chapter 8 is observation bias. This is another angle of predicting what the outcome is, like the wait time for the next train at a given time. So you take into account of the observer bias. Okay. Chapter 9 is about 2 dimensions. So you use a paintball example. The author applies the Bayesian framework to the 2-dimensional problem. In addition, the joint distribution, the marginal contribution, and the conditional distribution, all the interesting distribution you have there. So you don't think one-dimensional the Bayesian framework is challenging or confusing? Here goes a 2-dimensional one, or 3-dimensional one for that matter. Chapter 10 is about approximate Bayesian computation, or ABC. So when the likelihood of any particular data set that are very small and expensive to compute, or number 3, not really what we wanted. We don't really care about the likelihood of seeing the exact data set, but we just want to see what's the likelihood of having any data set like that. So that's approximate Bayesian computation. Chapter 11 is about hypothesis testing. So the Bayes factor, they give this definition of the Bayes factor, which is the ratio of the likelihood of a new scenario to that of the baseline. So it can be used to predict, to test the likelihood of a particular hypothesis. For example, the euro coin fairness or cheat. So if you have a calculator of the Bayes factor to be 1, 2, 3, it's probably not very good odd and not worth mentioning. 3 to 10 is substantial, and 10 to 30 is very strong, and 30 to 100 is very, very strong, and greater than 100 is very decisive. So like if you have to calculate the strength of the hypothesis. And number 12 is evidence. So you can test for the strength of the evidence. How strong is the evidence that the Alice is better than Bob, given their SAT scores when people are applying, when kids are applying to the school of a Harvard school, for example. They want to see how good the SAT score can correlate to the success of the applicant. In the case of the alumni for Harvard. So number 3 is about simulation. 13, chapter 13 about simulation. So you can, the author projected the, outlined the tumor growth based on the prior growth rate and the data points, the current tumor size and age, and etc. So you can plug in the your parameters and you can calculate the potential the growth rate. Okay. Number 14, chapter 14 is about a hierarchical model. So you put this is the structure of the system, which with the causes in the top and the effects in the bottom. Instead of solving this forward problem, we can actually reverse engineer the distribution of parameter given that data. The Geiger counter problem that was demonstrated in the book demonstrate connection between the causation and the hierarchical modeling. So if you really like challenging work, this is the chapter for you. Then number 15 is about dealing with dimensions. So the last chapter combines all the set lessons so far applies to the that's called a belly button bacteria prediction and simulation. So it's a very difficult chapter to understand and probably will require a full understanding of previous chapters, previous lessons. And that's kind of where I kind of doze off and gave up on the whole book. But anyway, it's the end of the book. I would say that for most people, if you are semi-technical, the first few chapters are interesting, 2 or 3 chapters are interesting, and unless you really want to go into the nitty-gritty of the Bayes theorem, you can read the rest of the chapter. But overall, I learned a lot, and there's a YouTube video you can find out how to how the author actually teach you how to calculate the odds of say Elvis, the probability of Elvis being his twin brother who died at birth is going to be is identical twin or non-identical twin, or I don't know what the other twins are. Anyway, so if the probability of being an identical twin. So that's very interesting application tidbits if you are into that. Overall, good book. Mr. Downey does a good job. I'm reading the Think Complexity. I finished the Think Python, and this is a good book. And hope you enjoy it. And go ahead and subscribe to my YouTube channel or my learnbyblogging.com. Thank you for listening, and I'll talk to you soon. Bye.